welcome. As you might have known, how many of you have attended any of the earlier ETEL sessions during the day? Well, a number of you at least, so okay, but you're all as welcome, of course. So this is about a working paper under the responsibility, in a way, of ETEL, together with several different stakeholders and actors. And the title is, How can EHR, electronic health record systems, or system clinical users make the best of algorithm-based tools? So, of course, you can interpret some AI connection into this as well, artificial intelligence, as we heard just before lunch, another discussion about. I will be the moderator during this session. My name is Michel Silvestri. I'm a senior advisor in the Swedish eHealth Agency. This is a government authority, and I would say more or less the national infrastructure agency of Sweden when it comes to digital health or e-health and health data. I've been working quite a lot on EHDS matters, that is European Health Data Space, both with the negotiations for the Act, the texts, but also in preparative EU projects of different kinds. Extended EHR is the ongoing that I'm actively involved in, and as you see by the logo up there, there's a connection here as well. Speaking of which, in this working paper, there is actually a specific deliverable mentioned from the Extended EHR project, D81, with the title Guidelines for Classification and Functional Profiles of Electronic Health Record Systems. Actually, this is the last one up for stakeholder consultation. So if you'd like to, if you have an interest, or I should be clear here, in this case it's a targeted stakeholder consultation, but I'm sure if your organization contacts the project, you will certainly get the possibility for your organization to provide comments to this deliverable. And that consultation starts on Monday, the 26th of January, actually. And it's quite a short consultation period, only 3 weeks. So you have to be quick, if so. But I would say that this is quite a central deliverable regarding these questions. With no further ado, I would like to ask Luc Nicolas from ETEL to come up here and give us a brief summary of the working paper. Right, Nicolas? So please.
Good afternoon, everybody. I will skip up a few slides. It's not moving. Yeah, the slides are not moving. Hello? No? Okay. So I will, yeah, you will come back to that after. So basically, I won't take a lot of time. The paper has been distributed. We have, as Michel has just mentioned, worked on a much longer report to support EHR, trying to see how far we can go in the verification of data in order to be able to use actually algorithm-based tools. And I need to say immediately that when we speak about algorithms, we immediately think about AI, but of course we used to rely on rule-based algorithms in the past. It's going to be less and less the case, I'm afraid. So indeed, algorithms and artificial intelligence today are semantically, intrinsically becoming linked. But from the Commission point of view, that was two completely separate work. But we're going to see that in practice, actually, those two worlds will go very closely, will have to work closely together. So when we speak about EHR systems and AI systems, the key question is say, well, what do we have today in EHR system? We have both structured, quite a little, and much unstructured textual documentation available. And you have a number of solutions today who have the promise, we've seen in previous session, maybe to help structure and code the data so that then it can be used by other algorithm tools, or to use structured data for more advanced care processes. So basically, the work we had to do is to say how to deal with interaction. What can we already do today? What should we do more tomorrow? And who should do it in order to make full profit of all that? So the key three messages that we have in this paper, and the first thing is that basically we should not look at the regulation in a too formal way, actually, which divides EHDS1 and EHDS2 in two separate worlds. That's not what will happen. Primary and secondary use of data need to be seen as an integrated ecosystem and not two separate worlds. People need to speak together, actors need to speak more together. So data fluidity, that means data needs to flow for whatever purpose. It means as fluidly as possible. That's the key message. The second one, but that's a very difficult one, is that even in countries, I'm speaking about my country in Belgium, where we have a patient summary operating and developed for GPs, the quality is not there. The quality is not there. We have data, but we have poor data. So data quality assurance is absolutely essential. And for that, the people need to see the value of the process to support this data quality assurance. And we'll see that we will need to go to conformity assessment of data sets, not only in the future of AI solutions, but on the data set. Are the data set which are produced by my organization, by me as a healthcare professional, ready to interact with an AI tool? And finally, we see that the industry needs to change quickly, because basically the old EHR industry, or EMR, if I take the HIMSS definition before, whatever, used to be very comfortable. Not very, but there has been consolidation. But basically now they see other developers coming, and they need to see how do we position ourselves. Do we develop ourselves, the AI solutions, and integrate it in the package, or do we need to interact and find a different way to work? And how? So they are possibly enablers, but they're also possibly blockers. And it depends in which country. So we have different configurations. We know that. For developing AI-supported algorithms, can be local, hybrid, or on the cloud. And actually, we will see that depending on the sensitivity of the data, often the solution chosen go from local, when it's extremely sensitive, to more cloud-based, when it's more administrative-based. So the main barriers, very quickly, they are, first of all, linked to the fact that, indeed, there is not data governance implemented in organizations, at least not sufficiently, and that semantic interoperability is not in the mind yet, or in the strategy of many healthcare organizations, at least not really in a detailed and implementable way. And we see that we are still spending huge amount of money. In Belgium, more than 55 million euro are spent to pay people to code data only for reimbursement. And those data are not used for anything else. And human coding, so one line by one line. That's what is the current situation. We see that, as I said, we don't have the quality of data that we need. We see also that you don't need a one-shot operation. We need continuous process, both in terms of governance and data conformity assessment. And finally, we see that we need to have something which is usable, so that the people do not have to click 5 or 6 times. We need user system designed solutions in order for this to happen. And so the key recommendation that we have is basically to evolve on the 3 pillar foundations. So where the verification of data is linked to data fluidity, so considering the use of the data for multiple purpose, and with the installation in healthcare organization of a real data quality process in assurance. And that can be, as you can see it, but I won't go into for the sake of time, into all the details here. But I want to insist on the first point. It's the semantic interoperability strategies require an investment by everybody. If you don't have public resources which have made available to healthcare organization, where the real controlled vocabularies are available in your language, it won't work. If you don't have a terminology server which helps people to map between resources, it won't work. If so, you need actually a lot of building blocks in order to do that. And you need also a lot of things at the organizational level to do that. But, so it's a collective successful story. Data quality assurance, you see that a lot, I've insisted already a lot on that. And then that point, balance, transparency, explainability, and seamless AI. That's also something really important. You ask people, they tell you, yeah, but I don't know where it's come, the data. And if you take the solutions out, they say, but why did you take it out? I liked it. So, you know, people are not always completely coherent. You need to find the right balance between all those things when you implement. And but this needs to be transparent and documented. So I will stop here because I want to give now the floor to Michel to animate the debate. I go back to those ones. Yes.
Excellent. Thank you, Luc. Very good. And again, the working papers, there are QR codes on the presentation. So if the audience want to look at the working papers, if you don't have them available yet, you can get them that way. And also with the folders, on the seats here. Excellent. Thank you. So I told you that we have a brilliant panel here, and actually I would like to introduce them properly to convince you about that. And we can start with Dragan. Since we have a bio which is also available on the Radical Health Festival website, of course, but just to say a few words about Dragan. Dragan Shapaski. He holds a Bachelor of Science degree in computer science. He's a deep tech innovator in digital health and co-founder, CTO of a company, Sourcix. And this company is behind a product called Pinga, a modular health operating system that powers national electronic health records and enterprise health solutions across Europe, Australasia, and North America, right? Yeah.
Yes, perfect.
Dragan has built more than 20 engineering teams and created Macedonia's most successful computer engineering internship program, mentoring over 250 young professionals. That's quite a legacy, right? Dragan, under his leadership, Pinga has grown to 300 healthcare sites, over 100,000 daily users, processing more than 3 billion clinical interactions. That's a lot of data, I guess. Yep. His achievements include national deployments in North Macedonia, in Serbia, and in New Zealand. And Dragan's work earned IHE Europe's X-Share Silver Label for EHDS interoperability, and also recognition by WHO Europe and the EU Health Directorate as a digital health success story. He serves also on WHO Strategic Partners Initiative for Data and Digital Health and the ETAL EHDS Technology Working Groups, and by their contributing to international standards as well as policy development. And I can also mention, just briefly, that you're co-author of a recent publication in Journal of Medical Internet Research with the title AI Act Compliance within the My Health at EU framework, a tutorial, which is very timely, of course, as well.
Yes.
So that is Dragan. I think that we give him a warm applause to start with. And
What an intro.
then we move on to, and I'll do that, to Jonas. And to say a few words about Jonas, he's a research associate at Fraunhofer Institute for Industrial Mathematics. There you have studied mathematics, but specifically you studied at the University of Münster and completed your doctoral studies at Bielefeld University in 2023. At the Institute of Fraunhofer, you've been working since that year, 2023, leading and managing research and industry projects in the department named Optimization in the Life Sciences. And this department work focuses on mathematics that support decision-making and helps to optimize processes. And also working on decision support for the effective solution of complex planning tasks with a focus on machine learning methods and their explainability also. So that sounds perfect for this discussion. A warm applause for Jonas as well. I thought for safety's sake that you get one warm hand each to start with. You never know at the end, so but well, I'm sure you will have it. Last but certainly not the least, we have Ana Benavent Navarro, and you have her on this slide. You serve as Director of Digital Strategy and Data at Park Tauli Consortium, which is like a hospital healthcare complex, if I got it correctly.
Yes.
And you're also Senior Health Data Advisor at TIC Salut y Social in Catalonia. This is an institution working to facilitate digital transformation projects in the field of healthcare and social welfare. You have more than 25 years of experience in public health institutions with leading initiatives to improve the patient journey, operational efficiency, and to streamline processes by leveraging the capabilities of digital technologies. And Anna has also extensive experience in data-driven decision-making implementation. In 2020, you were awarded the Outstanding CIO of Catalonia Award, and the year after, the ICT Woman of Catalonia Award. And Anna is, as you understand, committed to fostering partnerships between institutions, contributing to collaboration with the public and private sectors, and the formation of transdisciplinary teams to effectively address complex challenges, as the ones that we will discuss here today. A warm applause also to Anna. So with this, we can move on, and now the idea is to get your feedback on this working paper. So what would you say, having read this paper thoroughly, of course, what is your most important or what has been the most important or challenging things in the paper, and also what could or should be improved as you see it? Because this is still a working paper in progress, so to say. Should we start with Dragan?
Sure.
Yes?
Yeah.
Do you want to stand up here or?
No, I can.
Okay.
I will put this slide later. So, thank you for that lovely intro. I'll go straight to the question. So we are a company that produces EMR software. It's been implemented in many places, as you said. And I have to reflect on on our key points about this paper. First, I have to say the paper comes at a real good time. So everything is in the context of the EHDS regulation. But let's not forget that we have two big other regulations in effective now as well, which is the AI Act and also the GDPR, which is in place for 7 years, I think, already. So in all of this context, I think this paper opens very good issues that we face every day. And I want to mention some of them, of course, and they are in the paper. So data fluidity and data quality really address the problem around garbage in, garbage out. So in order to exchange data, in order to have messaging, and EHDS is around data exchange, you have to have certain data with a certain quality. And standards really discuss more about observability. How do you, which attributes can you have in your data or in your processes or in your messaging? But they don't really tell you how to do it that much, or they just tell you a bit maybe. So one of the key issues for us are data quality gaps that we see every day with the systems we integrate, of course. The other thing is semantic interoperability. So we can exchange data fields, but they have to be in the same data space. They have to be in the same ontologies, right? And if they're not, we have to have a clear way to map them. And the other would be vendor dynamics. So whenever you want to implement something, whenever you want to implement a change, you have to have constructive vendors, of course, like us, that are willing to do it. And sometimes you need to work coordinated with the other ones. And user-centered design, which is something about this paper, which is also mentioned in the paper. Please read it. So I have to say most EHR, this is not a green field, right? So most EHRs have been in place for 20, 30 years, and they were never designed. Firstly, they were not exclusively designed for clinical users. Most of them have been designed for billing, for rostering and scheduling, doing e-prescriptions, e-referrals. But the poor usability, I think, continues to dominate. And that's what we are seeing in the field with systems we try to integrate. AI can improve this, but also can make it worse sometimes. And governance and life cycle. So how do we go from legacy systems to current systems to future systems? Not all companies have the capacity and are innovative enough to adopt things really fast, and that's okay. And they can function like that, but how do we resolve that issue? We cannot always have startups bleeding edge technology or companies deploying. I'm an engineer, so I come from an engineering background, and I have to stress this, how important it is. And the last point I want to make that we're seeing, so the EHR, the extended EHR, the European extended EHR format now, which is in the EHDS regulation, has to have some space to say which data fields have been generated by AI, produced by AI, or semi-produced by AI. So AI maybe has produced them, but you have human-in-the-loop systems. So we have to have a way to annotate this, because we will see AI-generated data or summarized data more and more, right? And I have to say, I'll skip some of the slides because you gave us such a good intro. I'll go straight to one of our key modules of our system. So our system is a very configurable platform. And I want to mention why we did this module, and you can see it in the exhibition stand. We have a stand here, so you can see a live demo. So we have this pathway builder module where we build the clinical processes, but not only clinical processes, of all kinds of processes, administrative processes, etc. Why? Because the core issue that we need to address is how is data created. So data is created in some clinical process, then it goes to a data model, then it's interoperable, it's exchanged via messages, comes into clinical data repositories, data marts, and then you use AI models on several of these levels. But if you don't address the creation, the actual creation of the data and how the process should flow, you really have your hands tied in many ways. So our pathway builder is actually this, and we use it to model various things, not only clinical processes. And I also have to mention that that's why it was easy to implement the yellow button, which is like an export exchange mechanism of your entire record or just a summary via this module. So I have to say, also, I'm very frustrated sometimes that clinical end users or providers are sometimes buying just IT systems. So also in radical health, you can see that many people are talking about value-based care. So the real question is, and you can solve many of these issues, is by answering this question, is how to align value-based care with technology. So you cannot only implement technology and someone else think about the problem. The user, the provider, has to ask the implementer to implement value-based care with technology, but the output should be clear, that you want clear output of clinical improvements and of the clinical processes, not just purchasing technology. So very often they have tenders and we apply, but it's about technology and someone else needs to take care about the outcomes, but this doesn't work. So you have to address the problem at its core, which is figuring out the right process and how you really create data and how you work in real life. I hope that was...
Excellent. Thank you so much, Dragan. And with that, I think we move on to Jonas. Do you want the first slide up
Yes.
right away? Yeah.
Thank you.
You choose if you want to sit or stand down here. And as you understood, when I approach you a little bit, then you see you get the signal, right? Yeah. About time, I mean.
So I'm from Fraunhofer Institute for Industrial Mathematics, one of 70 institutes all over Germany, and we are one of 2 mathematical institutes at Fraunhofer. And yeah, we focus on both mathematical methods and their application. And one could ask, why should a mathematician be involved in medical projects, maybe? But yeah, in general, it's often the case that potential customers come to us with complex problems that are not mathematically described yet, but they have the idea that they want to have a better solution for this problem, and maybe mathematicians can help with it. And often it's a case that we try to together to work out a precise description of the problems of the potential customers. And yeah, then we do not only work on the mathematical methods, publishing scientific papers, for example, and we do not only develop a simple standard software, but we try to think both of this together. Develop a software that includes advanced mathematical methods. That's what we are doing together with our customers or project partners. I'm personally working in optimization in life sciences. That means all of our projects are connected by the application field of life sciences. For example, medical or care processes are supported by us. Potential project fields are, for example, operation research, like finding optimal schedules for medical personnel plans that is only loosely connected to the medical perspective. But another example is optimization of therapy plans, which is, for example, the optimization of the radiation dose for tumor and surrounding tissue in radiotherapy for cancer. That is more involved in the medical application field, just to give 2 examples. Today I'm speaking about decision support and how it is affected by the data quality. So just to understand that, what we understand under clinical decision support, that is we are giving treatment recommendations. That is, the human is in control, as Dragan already mentioned, that is important. The medical expert can make its own decision based on recommendations. These recommendations are based on the incoming patient data, of course, so, for example, from the patient documentation. Then on a knowledge base, that is, for example, an AI model or a guideline knowledge, which is somehow presented to the user. And we try to integrate the database and the knowledge base with our problem-solving skills, such that training an AI model or encoding guideline knowledge, such that we get treatment recommendations for that automatically. Our systems then allow to compare and combine these recommendations from different methods. And if we use black box models, we ensure transparency by using explainable AI methods for the decisions. Of course, data are relevant in this process as the basis for every single decision on a patient and also for the training on AI models. And therefore, the availability of high-quality data is, of course, an important foundation for us. But we try to use hybrid systems in the sense that we also try to integrate the view of the literature into our decision support tools. That is due to the fact that high quality data are not always available yet. And we can thinking about reducing that impact of the guidelines if we have better data available. What is important about the fair data and EHDS concepts? I think these concepts exactly should do this, that they facilitate providing high quality data for researchers. And however, in practice, they are not implemented yet in in many cases. And that is because of, from my point of view, the protection of personal health data that makes assessing the data more complicated. But I think the EHDS provides a regulatory basis for that, and having a clear regulatory basis, I think that is essential to reduce insecurity in the regulatory basis, and that at the moment I personally feel is an additional burden at the moment for the innovation. And moreover, in practice, medical data are often not collected in structured format yet. That makes finding and reusing these data complicated. And the concepts define desirable goals, I think, and support high quality health data. But how can we reach these goals? I think for this purpose, all stakeholders, medical experts, data experts, and legal experts, also the EHDR vendors have to work together to improve data quality. And then fair data and the EHDS will allow support, clinical decision support on the broader foundation.
Thank you so much, Jonas. So I can take that one. Then with that, I think we hand over to Anna to give your perspective on this, please.
Yes. I would like to start just saying one thing that has been said before, because we are in a moment that maybe we have been making digitalization projects from maybe 20 or 30 years. So at the end, I think that there is one inertia that we have in the hospital or in the systems. And when we have some papers, the paper that we are presenting now, it would be much more easy if we start from scratch. For example, if we start from the paper. I know that this is not the situation that we would like, but we don't have to start doing something new. We have to change what we are doing now, and we cannot stop what is doing now. And so this is where I think that is the real challenge of the paper. So I think that this is the same that if we say that the strategy is one thing, and the culture in the organizations or in the reality is another thing, and there is a gap between one and the other. So I think that the other point that is very interesting is the time, or it's a challenge, is the time. You have said that how the vendors can make all the changes so fast, and I think that 2029 is too far away. I would prefer that the things would be mandatory that to be applied before. I know that is not possible from a technical point of view and even from the organizational point of view. But at least we have to align the things that we are doing now in order that assure that we will have in the 2029 would be what we want to be. Because the problem is that in between the period, for example, that the act is not mandatory, vendors can continue developing things that are not aligned with the European health data space. So at the end in this very moment, I think that it should be mandatory not to do anything that is not aligned with that. Because if we never stop what we are doing, we won't be able to do the things different in 5 or in 10 years. Okay? So I think that this I think that is what Peter Drucker say, that the strategy, it's the culture, it's a strategy for breakfast. And at the end is that we have made a paper that it's very nice, but when we come back to our reality, the reality is another thing. The reality is very hard, and the reality differs from what we are talking here. And another question related with the time, I think it's when we say about one of the 5 barriers that there is a lack of continuous governance and iterative design. And it's been said a lot of times that the clinicians have to participate in the design, and the design has to be done not one time, if not that we have to do it in iterative way. Then I'm asking how the clinicians can dedicate time to that things if they don't have enough time for doing what they say that is their main goal, that is being for the patients. If we have a waiting list, for example, in the public hospitals that we don't know how to solve it. So what happens usually, or I experience in these 20 years, that when you have a group of group with multi-proposal group with different kind of professionals, who is the clinical that goes to this group? Is the younger clinician that they have in the specialty, because usually the clinicians that want to work or do something with the technology are the youngers, and the youngers doesn't know the knowledge that have the senior ones. So at the end, what happens? That the senior ones sometimes even didn't read what has been said in the meetings or in the decision places. So when they see the result doesn't fit with the necessity. So I know that as senior people, and it's one of, for example, for me, I cannot be everywhere. But how we assure that the people that are designing things that have to dedicate time are the people that have the right knowledge for doing that, assuring that they are representing the needs that fit with all of their colleagues. And I think that for the first presentation, that's enough, as we will talk later a little bit more.
Very good. Thank you, Anna. Good perspectives from all of you. Before moving on maybe with the next major question, I would like just to have a short follow-up of what you've been discussing now. And I think actually also Luc indicated this a bit in your introduction. From your views and what you've said this far, this title, EHR-Algorithm Communication, the EHDS regulation is about both primary use of health data for healthcare, maybe even social care, and also secondary use, that is reuse of health data, mostly for other purposes, research, innovation, AI or algorithm training, etc. From these views that you've described, would you say that you've talked mainly from a primary use perspective with the complexities we have there, from a secondary use perspective with maybe developing products of this kind, or a mixture of them, a hybrid maybe? What do you say, Anna?
I think that we are not able to separate primary and the secondary use of the data. Obviously, we can do some things that are direct related with one or the other one, but at the end, we're talking about the same. What are we talking about? About the data spaces. So the data spaces have the meaning for the primary care and the secondary use. So I think that it's a hybrid for everything. And in fact, in the paper, we talk about, for example, the AI models have the cause and the consequence, because we want good quality of the data for applying a good AI models, but at the same time, we need the AI models for having the good quality of the data, because we are not able to do that just manually or with the technical. So at the end, everything, it's a loop, and it's all feedback. One thing, it's feedback the other. I don't know how to say that.
Hopefully it's a feedback. Yeah,
okay, but we are in the loop.
Yeah.
Not the human in the loop, so much more another one.
Yes. Good. Jonas, what's your view on that?
Maybe I can add, as the only one who's not a provider or part of a big hospital here, as a third party, it's always immensely difficult to get data for training, to get data for testing, because of assessing data is so problematic since we have this personal health data which are especially protected. And if EHDS can help there and can make data more accessible to third-party data, that would help us a lot for work if we can access data more easily. Because it's often in project that huge amounts of time are used for finding a good solution for sharing data, and that takes too much time from my impression. And also not only for us, but also for our medical partners.
Okay. And in your institution, optimization in life sciences, as the name is, what would you say is your main focus there? Is it primary use or secondary use? Or a mix of it?
I mean, it's basically a mix of both.
Yeah, okay. Sounds good, but even more complex at the same time, maybe. Yeah. Dragan, what's your view on this?
I have much to say about this. I would like to have one case. So we have a national EHR system in North Macedonia running for 13 years already. And the system is online and it's real time. So primary exchange of data is real time, but also secondary use of data can be real time, almost real, doesn't have to be real time, but can be like with a latency of 1 day or 1 week, which is considered pretty short and pretty low. And there's always challenge how to access this data, or what is protected under GDPR and other laws, what's not. So I view this as a data onion. So like you peel the onion, layer by layer, that's how you need to think about secondary use of data. So the smallest layer in the middle is like the personal data. Then if you think about it, how to create several layers on top, which is statistically summarized data, and then summarized even more, and then you go to the top layer, which would be open data, accessible for all the public. So open data until the personal data. There are layers like in an onion here, and if you think about data in this way, I think you can succeed. So the layers in North Macedonia are clinical users, doctors who know to do data analytics. We supply them with access to the system, for secondary use, to a data warehouse, data mart, which is anonymized data and sometimes semi-anonymized. And even if you need to tackle on the personal data, you can do that in a way, either online directly or offline, someone doing the analytics for you. I think if we have this mindset, it's a good way to think about it. And with this mindset, I think we can have secondary use which is successful and not that much expensive. But it continues to be a large challenge for us.
Okay, that's a good picture with the onion model of different layers like that. Very good, thank you. If we move on to a slightly different question maybe, or trying to look into the future. Do you have any ideas or perspectives on what could be expected to be deployed in the next, say, 2 or 3 years? And what would be the expected changes for each actor, or different actors at least? Would you like to start, Dragan?
Sure. I have to say, I just an hour ago, I learned a Finnish phrase called sisu, which means grit and courage. So we really have to have sisu now and really implement something in real life. So I want to do a scenario. Yesterday there was a great panel about women's health. It's what's called Women's Health Data Challenge. And last week with my friend Sanya from the ministry, who was on the panel. I hope you were there as well. She talked about an interesting case, a story where we have a national EHR system, or a national system who sends birthday cards. And the birthday card would be something like this. Subject, a personal health recommendation for Anna. So Anna is having her 45th birthday today, and the system sends her a message via email or SMS or whatever we have in the country. Dear Anna, based on your health record and national guidelines, it's time for your first breast cancer screening. So we've pre-selected some appointment options near you or near your GP where you go regularly. So she taps on the message, the portal will show a short explanation why she's being invited now, being 45, etc. And a visual timeline of her past preventive care, vaccinations, cervical screening, and pregnancies. So the system will suggest some appointment slots for her. And the final message would be, this recommendation is generated automatically using data from your electronic health record, and it would mention EHDS exchange of data, etc. So what's happening in the background? Well, let's say we have a core EHR system on a national or regional level, and we have the breast screening system as a separate system. So they exchange data via EHDS messages in the EHDS domain. They exchange demographics, care relationship, where's the GP, where's the practice, where's the gynecologist, etc., but also clinical history. So in the discharge summaries in the EHDS domain, you would have obstetric history, the history, Anna had 2 pregnancies, what was the dates of the breastfeeding, the duration of the breastfeeding, and a coded family history saying that her mother had breast cancer at 62 years old. Also, Anna had some hormone therapy in her late 30s. Ideally, we would have also a BMI trajectory. So this is not rocket science, right? Actually, it's something you would expect from a system, but it's not the case in many places. So I see the topic we're discussing now in EHDS as elevating this minimum standard. So to achieve this, sometimes it's not ideal. So let's say the medical history is not coded. So we know that Anna's mother had breast cancer at 62, but this is written in a PDF somewhere. And for that PDF, we used an AI model to parse it and to extract this data from the PDF. And when we produce it and exchange it with the breast screening system, we have to say that this data has been produced by AI, but with a human-in-the-loop check. So we have the exact provenance here. For me, this would be ideal, and this is something we use already. So I think we need to think about this more. I think this would be the ideal case in many scenarios, and I think it's not easy to do it, especially in brownfield systems who already have systems in place.
Thank you. Should we jump to Anna, maybe? What do you say?
I say that maybe in the next 2 years, that was what you are asking. Well, next 2-3 years, I think that the things will be more or less like the same that are now. Okay, but maybe in 10 years, and I think that we need a lot of workforce from outside of the healthcare space, because when, for example, you're talking about in Macedonia, you have a national electronic health system that is it's national, no? So it's much easier to build things upon a base, no? That the base is the same and it's homogeneous for the same. But in the moment that we start to exchange in real-time information about all the countries in Europe, everyone will have another task that we don't have now, that is to take care of the data that is going outside, or that from outside they are asking to you. So at the end, it will be much more task to do than the task that we are doing now. And this is a thing that, for example, in Catalonia, and I would like to explain an example from there, we have an heterogeneous systems of the electronic health record systems in the hospitals. So at the end, we are leading or battling with the interoperability for a long time ago. And we have achieved to have a centralized repositories. And this is a thing that sometimes when I'm listening though, to the Finland, the example of the Finland or the Singapore, they are much more far away from us, but because they are starting from a different point of at the beginning. So, and when we have the European Health Data Space implemented in European, we will be in a scenario that maybe we are in Catalonia now. So, what is the example that I would like to explain is that we are now developing an AI centralized platform in order that all the AI models were deployed in that platform. So this is an structure that we have started for 3 user case use at the beginning. No? The first is a digital solution based on generative AI to offer an information and resolve doubts about medicines to the patients and to the citizens. And this is one of the use cases that we will do in this platform. The second one is an artificial intelligence model to support diabetic retinopathy screening for the eyes. And the third one corresponds a set of AI tools applied to the digitized images for pathological anatomy. So what happened with that platform and with the different algorithms that are being developing in the different hospitals? So as we have talked in the paper, there are 3 models of develop that. One, the ideal is that all the AI models were developed with the technical stack or the framework that is provided for this platform. This is the ideal, because then you have the code of the program, so you can review the versions that if they are using all the tools that is necessary to use and the appropriate tools for developing the model AI. And if the model, for example, is working well or not, and so on. But most of the reality is that the vendors won't give never the code, because it's their gem. Yeah. Is the effort for a lot of years. So this is one of the problems that it's not a problem for the AI models. It's a problem that we have been for always, that the vendor, the competitive advantage that they have from the others is the code. So when we are asking for the code, they say no. Maybe if you want, I will give to you a binary pack, no? That the solution, you can do some things, but not the code. And this is a thing that is not solved, but because we are in different worlds, I think, not in different layers, in different worlds. Because one thing is the private world of the companies, and another world is the clients, and especially if you are public, your private is very different. So we are trying to do that, and there are some examples, but it's different. It's very difficult. It's very easy to put in a paper, but in the reality, it's like to see. It's like the wars that are in the world now. See people that have a different interest from the heart. So it's not so easy to understand. But we are trying about that. And now that is one of the things that I would.
Can I chime in a bit?
A brief comment to that. Yeah.
Sure. One of the ways we solve this is by having an open data model, because we are in the information system space. We work with data, right? So I think vendors should open up their data models. Yeah, they can open up their code, but code is changed every day. So, but if you open up the data models, and you know the exact governance, how they're upgraded, then you can use them beyond just having APIs and for secondary use as well. So I think this is the way vendors should think more and more, and should not be afraid about opening up things, because vendors need to be flexible and moving fast, and not just rely on some old code, and this is evolving every day.
I just want to say one thing. Obviously, the solution, there are some things that we know about the solution. We have to use the standards, all the things that we say, no? The standards, the interoperability, the open source platforms. But at the end, if using all of that things, at the end, there is one difficult that is that difficult, that they are leading for the competitive advantage in the private world. So we are going to in different ways. We are trying to do everything open, and then where is the business for them?
It's an ambition, a vision, but it's not that easy. But at the same time, this working paper touches upon this, if you call it the proprietary challenge or locked-in data, or what you would call it. So that's a good thing, but it could maybe be elaborated further in the paper as well. So please, Jonas.
Yeah, maybe let's I will just try to add a few points. Many things have been said already. So there are many different tasks in medicine, and I think documentation or structured data will be supported next. So I agree with Dragan there that especially if you try to extract data, there will be a lot of validation tasks, and that will be important to get models we can trust in, and to get this trust will be important, I think. And another part of medicine is, of course, assisting therapy and diagnostics. And there, I think sync context will be very different. So the number of patients which are involved in a process, or the effort physicians put in it, also the density of the collection of data will be very much different. And there will be, or there already are maybe tasks like recognition of tumors and image data, which is a clear part where an AI can do a good job, I think. But also, on the other hand, there can be areas like, if you look at general practitioners, for example, they may not collect all the information they have about the patient in their data records, but they may choose medical treatment diagnosis based on their overall impression they have from the patient. And this is hard to reflect for AI models, to give this to AI models. And I think their assistance is very much more difficult. And on the other hand, Anna also mentioned that there are a lot of different sources of information, and they should be collected in a repository. And this will also affect the deployment of AI models, I think, because if you want to collect data from many different sources, that will be rely very much on the infrastructure we have and on the possibilities of exchange. And this will also force or hinder the deployment of AI models, I think. Good point.
Very good, thank you. I think actually we have, we'll stop my questioning or my questions here, and then see if there is any questions from the audience. We have a so-called running microphone here, so anyone who wants to ask a question to the panel about what we've discussed. We have actually a lady down there.
Hello. Yes. I'm Bisana, data scientist with Love Air, and I have a question about the AI-generated data to feed into the AI models that you have mentioned. So, as a data scientist, when I get to work and I have a Excel sheet, maybe with patients, I often try to remind myself that these are real people and not just data points. Yes. And with real people, data is very diverse. We have extreme cases that we can't always put to the side as an outlier. So I was wondering, how do we strike the balance between generated data and real data? And how can we make sure that the generated data can emulate the randomness and the spontaneity of real human data?
Good, thank you. Anyone who wants to take on that question?
Yes.
I think I can't give a general answer, but I think if we annotate the data and say that it's augmented or generated by AI, this is better. So if we have a BMI calculation, everyone knows how it's a function of the weight and the height. But with so just look at AI as a non-deterministic algorithm, and that we can say that this was generated by this and that with this method, and we don't. There's no determinism here. I think that would be a good starting point. But yeah, it's a great challenge, especially around missing data and historic data. Yeah, it's a great field to work in.
An additional brief comment?
Maybe to add on this. Maybe it could also be an approach to try to train AIs in that way that they can do the everyday things, that not every outlier is covered by the models, but doing some sort of standard patients or patients that are closer to the standard cases, that will be easier to cover than every outlier by an AI model, I think.
Thank you so much. I think by that maybe we will close this session. And to start with, I hope that you will be available maybe for additional work on the paper, some polishing of it. I will be at least. So, but it looks very promising, I think. I just conclude it with one word actually from this discussion. And it's the Finnish word that was mentioned, sisu. Actually, I was looking a little bit at my colleague Mikael Rinetmäki from the Valo project, the Nordic project. We discussed it the other day, that if we talk EHDS preparations and implementations in general, it's really important that we will have endurance. And in a Finnish word, maybe sisu, so that we don't give up, because it won't be an easy journey, right? So we know that. Yes. And I think you've described that from different perspectives in a very good way. So thank you so much. Thank you to the audience, and thank you to the panel.
Thank you all.